The subject of this presentation is analysis of human body movement patterns and false detection. The authors are Andrzejewski, Zając, Karasiński, and Królikowski. The first three authors are from the Jacob of Paradise University, Gorzów Wielkopolski, and the fourth one is from the Koszalin University of Technology, Koszalin. The presentation is divided in four elements. First one will be short introduction. Then we will discuss fault detection prevention problem. Then we will present effective method of physical activity monitoring, and then we come to the conclusion. And now a few words of introduction. The structure of societies worldwide is changing to contain more and more people over 65 years. And it is reported that 1 in 3 of them falls at least once each year or more. And the falls are reported to be the most important cause of fatal and non-fatal injuries, which is a huge problem in fact. And what's more, even exposure to risk of fall is itself a significant problem. And there are designed dedicated systems to monitor human body movement parameters, and system monitor the patient and report the fall accident, but they do not allow to detect potential dangerous situations or to monitor in long term the changes in person's motorics, which would allow to take prevention measures against risk of falls. Falls detection systems are of two types. They could be mobile and wearable with wireless transmitters and alarm buttons, and they could be stationary using local infrastructure of rooms, buildings, selected areas, and so on, which are based on video monitoring with image recognition and floor vibration detectors. And in the systems, fall detection is achieved by use of accelerometers and gyroscopes as body fixed sensors, or image analysis and floor vibration systems. And systems are designed to detect certain events of physical conditions of patients under observation, but do not prevent falls. The concept of physical activity monitoring is using the following mathematical foundation. Location of a single P point in 3D space, which is Cartesian space, is uniquely described by ordered triplet T of real numbers x, y, and z. This is the red spot in the picture. Movement of an object located in this space forms a trajectory. If the observation takes place in discrete time domain, the discrete trajectory TD is a set comprising triplets x, y, and z planes in discrete time domain, and the difference T delta between triplet Tn-1 and Tn determines Cartesian space displacement of observed point T delta. Discrete trajectory analysis can be used to determine the dynamics of human body movements. Dynamics data analysis allows us to detect dangerous situations as falls, stumbles, tilts, etc. And what's more, it allows to monitor slow changes in healthcare conditions and even to predict the risks or probability of occurring dangerous situations in the future. And the data can be statistically filtered to extract required features of the signal. As statistic filtering mechanism, there was used Poincaré plot, and in discrete trajectory TD, the distance between two subsequent points P1 and P2 is determined by displacement vector V. And let denote the set of lengths L of vectors of subsequent displacements V as L. And then Poincaré plot PP of subsequent elements of L is given as the formula here, and a PP gradient is analyzed as effective motorics indicator. It was carried on an experiment involving 9 volunteers, and the sensor was attached to subject belt, and there were analyzed measurements during walk, stumble and fall situation, and the measurements of accelerometer sensors were recorded. And this slide presents a plot of displacement vectors from the L matrix during walking in the left one, and in the fall situation to the right. It could be noticed that the walking situation contains far less changes in the plot, and the fall situation contains very high value of changes in the signal. Displacement vectors data from the L matrix were analyzed by Poincaré series, and the plot of that series is presented in this slide. The left picture shows Poincaré series plot during walking. It is not very much dynamic. The right picture shows the situation of the fall, and we can easily see that the plot is very complex. Next pictures show summarized three-dimensional Poincaré plot gradients, and it is clearly visible that the amplitude of the signal is much higher in case of dangerous situations such as falls. In the final picture there is shown results of analysis of data for a number of different incidents. And the image indicates that the gradient of fall situation is far more distinctive than the gradient of the signal in the case of non-fall situations, such as a walk, even a stumble. The research and experiments indicate that the gradient of PP can be an effective measure for analysis of human body movement, and especially to detect dangerous situations as stumbles, falls, and similar. And it could be used to expand functionality of existing systems, for example, to analyze long-term tendencies basing on statistics of falls or so, and to automate decisions whether there is an urgent need for help, or it is not urgent, or perhaps it is no need at all to take an action. Calculation could be implemented in a dedicated chip such as FPGA or microsystem, and the further research would be to determine classifiers for alarm triggering with self-learning capabilities, and to develop a method to predict increasing probability or risk of possible fall of a person. Thank you for your attention.